The majority of drugs are currently made industrially in enormous pharmaceutical complexes and are shipped from there. However, the plants that these drugs or their active ingredients originally came from naturally make these, which means they have genes to do so. By taking these genes, rationally engineering them, and putting them into yeast, the modified yeast can gain the ability to make these drugs or active ingredients upon fermentation. The system allows drugs to be made anywhere that a person can take the yeast. It allows for a portable pharmaceutical processing plant and can be scaled. This method of manufacturing would only require water, sugar, and the yeast itself, making it the first entirely renewable source of therapeutics. It means that the prerequisite materials, sugar and water, are no longer subject to the regulations of transporting chemicals, and so can be transported more easily and safely. Also, unlike many precursor chemicals, sugar and water have an indefinite storage life and require minimal storage conditions. What we are proposing has already been done with opioids. The groundwork has already been published and is readily available. The yeast itself is able to be dried and stored easily and is a well understood, versatile, safe organism, free from the public concern or worry that exists with bacteria or animal involvement. The system allows for the same expression units to be used to express different drugs by only changing the strain of yeast within them, reducing or removing the need for different machines to be used in various stages of manufacture, or to design and develop new machines to fit requirements. Additionally, the scalability opens the possibility of disseminating the technology as desired, whether one wants to synthesize therapeutics centrally or license their synthesis to others. The modified yeast can perform as many processes to make a drug as they have genes, and so as many as are necessary in the same amount of space. Whether making a simple or a complex molecule, the modified yeast will do it in the same amount of space, with no difference in effort from the person using it, being that it conducts all stages of synthesis in the same reactor, and requires no intervention, which doing so, the system affords the user minimal interaction time, and there is a distinct prospect of a high level of automation. If Dartum Limited receives this funding, it would mean that we can grow from an idea stage to an actual product. This funding will help us take this whole project off the ground and give the university and labs and drug industries an alternative and efficient way of synthesizing drug molecules. Many people in the world are suffering because they lack access to essential medication. In the long run, this may prove a cheap solution for producing essential drugs. Thank you for watching.